All right. October, November 2020, P319608. Question number 1. In a particular computer system, real numbers are stored using floating point representation with 12 bits for mantissa and 4 bits for exponent, whose complement form for both mantissa and exponent. The following floating point number stored is not normalized. So what we have to do, we have to first normalize it. Calculate the denary value for the floating point number. Maybe if they have, in any case, when you get a question which is not normalized, first you have to check the part after it. If the next part says to normalize it, you don't have to normalize in the previous part. If it does not, then you would have to normalize it in the previous part. Since it says that you have to normalize it, so normalization will not be carried out over here. So let's solve 1, 2, 3, 4, 1, 1, 1, 2, 3, 4, 5, 6, and exponent is 0, 1, 0, 1. So this one is 0.00011 into 2 to power 1245. So point will move 5 times forward. 1, 2, 3, 4, 5 here. So this will become 11.0. Okay, so if it is 11.0, it means that it is plus 3. All right, and since it is a real value representation in floating point numbers, it is plus 3.0. All right, so you might see in marking scheme, it is just 3 or maybe it's plus 3 or whatever, just leave it. Normalize the floating point number given in part A, normalize it. So let's normalize it. If we normalize it, in that case, we will first mark first 2 different characters, and whatever the number of bits in between these 2 different bits, we will subtract it. So this will become 0, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1. Oh, sorry. So this is now 5. So how many bits we have taken out? 3. So 5 minus 3 becomes 2. So this will become 2. So now 0.11 into 2 to power 2. So point will move 2 points right. So this is the same result as we had over here. So this is still plus 3.0. Okay, so this is normalized value. So let's put that normalized value 0, 1, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, and exponent will be 2. Okay, describe one problem that can occur when floating point numbers are not normalized. Okay, so bits are dropped that actually compromises on precision. Bits are dropped from least significant bit side or the right side. Okay. The result is changed. Whenever you lose bits, the precision is disturbed. Precision is disturbed, the decimal part of the question will be changed. So the whole number will get changed. Now, question number 2. Data types can be classified as composite or non-composite. Composite are those which are using other data types, whereas non-composite are those which are not using other data types. Like this is a list, enumerations. It does not have any other data type. If you are thinking that these are strings, no, these are not. Had that been a string, they would have been enclosed in double quotation. So there is no double quotation. So this is not a string. This is just itself the value, the constant. All right, so the data, it is part of this. A record is declared of type box using the following pseudocode. Type size, this is basically what? This is basically an enumeration. and this is your record data type. Type box, this is volume of size, which is out of enumeration, price, which is real, declare color as string, and type. Declare my box array of 1 of 6 of box. Okay, so now this is an array holding all these three values at every element. But remember, this is not two-dimensional array. It is still single-dimensional array. This is still single-dimensional array. Identify one composite and three non-composite data types used in the pseudo code. So the one that is composite data type is definitely box, because composite data types are those which are made up of other data types. So this box is made up of size and real and string. Non-composite data type is this. First one, it is size. So then we have got real. Real is also not made up of any other thing. Real is itself real, which cannot be further divided. So it is non-composite. It is not made up of any other data type. Similarly for a string. A string is just itself a string, so it is not made up of any other data type. Identify the data type in the pseudocode that is enumerated, which is size, obviously. Enumeration are lists. A box is read. Okay, first we have to check what was the name of array, my box. Okay, a box, and what are the volume, price, color. Okay, a box is read with volume, with medium volume and price of 10.99. So write pseudocode to store the details of this box in the first element, means the index of the array will be 1. So the name of array is my box. My box 1 dot, we have volume, price, color. Volume. My box 2 dot price. My box 1 dot color. All right, so volume is medium. Remember, this volume is out of size. Size, if it would have any value, it will be out of these three values, which are not string. Okay, so when we put the value over here, we won't be putting it in any double quotation or anything. All right, so the price are 10.99, and color, since it is a string, it is red, so we are going to put it in double quotation. Color, it is mentioned that it is basically a string. Okay, now question number 3. The use of the TCP/IP protocol suite is essential for successful communication over the internet. Describe the TCP/IP protocol. All right. It is a layered protocol. It is a layered protocol. Or layered protocol model. Okay. It has 4 layers. Okay. Those 4 layers are application layer, namely application layer, transport layer, network layer, which is also called internet layer, and application layer, transport layer, transmission layer, application, transport layer, data link layer, data link layer. Okay, now that's it. Describe it. It is a layered protocol model. It has 4 layers. Every layer may have, not may have, rather have, every layer has other protocols. Okay. It controls the preparation, delivery, and consistency of data in transmission. Okay. So it is a layered protocol model. It has 4 layers, namely application, transport, data link, and network layer. Every layer has other protocols too. It controls the preparation, delivery, and consistency of data and data transmission. Okay. A group of 100 students has produced a movie. The size of the movie file is very large. The students would like to use peer-to-peer file sharing to share this file with friends and family. Identify most appropriate TCP/IP protocol for sharing this file over the internet and describe way this protocol works. So if you do remember, only peer-to-peer network protocol that we have studied in our syllabus is BitTorrent. And since overall the internet works TCP/IP, so it is also a TCP/IP protocol. So this is BitTorrent. Okay. Now it is 5 marks question. 1 mark you get for the name. In here, the file in BitTorrent is called torrent. Okay, it is called torrent. Everyone has to download and run the torrent client. Okay, everyone has to run a torrent client. Everyone who has ever downloaded a file also has torrent, which is the torrent file. Okay. Torrent file is split into pieces. Okay. A server provides the details of torrent holding computers called seeds. Okay. those who download are connected to seeds and download. While downloading, user becomes a seed too. I think that's it. This is just 5 marks. You don't have to write the whole thing, but there is a lot more that you can write about BitTorrent. This is just like 30% of the whole story. All right. So do visit marking scheme to get the whole account or the notes or my recorded lecture, whatever that you can get hold of. All right. To review the whole thing. Now 3B, files shared over the internet are sent using packet switching or circuit switching. Identify and describe the most suitable method for the large movie file from part A2. That must be packet switching. It must be packet switching. All right, so a movie file is divided into packets. Movie file is divided into packets. Packets have header that holds origination IP, recipient IP, data, the number of the packet, hop number, and so on and so forth, and payload, which actually is the data itself. Each packet is independently moved over networks. All right. Packets are routed over the network or internet through routers. Packets, when reach destination, are reassembled. Okay. Stray few packets got stray and are found by their diminished hop number and are killed by router. Okay. Remember I told you that every packet in its header is given a hop number, that is an estimation of number of times it passes through the routers when it is actually heading to the destination. Every router decreases that number by 1. If the packet for any reason has got corrupted or its information has been amended, it won't be able to reach at the destination as the information would have become corrupted or changed or whatever. So the hop number will get reduced at every router and eventually it will be 0. So if a router finds a packet with 0 hop number, it kills it. All right. Okay. So state one benefit and one drawback of the method you identified in part B1. Benefit: packets are small sized, so do not stuck. Okay. They are rerouted when reach congested routes. Okay. Drawback: a delay can occur because of delayed longer routes holding packets and stray packets. Okay, so if packets are taking a longer route because they are actually in a congested route, they will be reaching late. Or if the packet becomes a stray or corrupted, so it will be killed, so it will be actually asked by the sender to be resent. So that might give you a delay. Now, question number 4. Following truth table represents a logic circuit with 3 inputs and 2 outputs. Write the Boolean expression for the truth table as sum of the product. Okay, so for X, we have got this 1, 1, 1, and 1. So this is A naught, B naught, C. This is A naught, B, C naught. This is A, B naught, C naught. And this is A, B, C. So X is equal to A naught, B naught, C, or this is sum of products, right? A, B, C naught, or A, B naught, C naught, or A, B, C. Now, for Y, we have got this 1, 1, 1, and 1. So A naught, B, C, A, B naught, C, A, B, C naught, A, B, C. So we have Y is equal to A naught, B, C, plus A, B naught, C, plus A, B, C naught, plus A, B, C. Okay. Now, part B. Complete the Karnaugh map, K maps for the truth tables. So for X, we have 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 1. So 0, 0, 1. So 0, 0, 1, 0, 0, 1. Here we go. 0, 1, 0, 0, 1, 0. Here we go. 1, 0, 0, 1, 0, 0, and triple 1, and triple 1. Okay. So this is for X, and now for Y, 0, 1, 1, 0, 1, 0, 0, 0, 1, 1, 1, 1. So 0, 1, 1, 0, 1, 0, 0, 0, 1, and 1, 1, 1. Okay. So we have done it. Now part C. K maps can be used to simplify one of the expression in part A. Okay, draw loops around appropriate groups of ones to produce an optimal sum of products for the single output table that can be simplified in part B. Write the simplified sum of product expression of the output from part C1. Draw loops around appropriate groups of ones producing an optimal. Okay, so Again, part C key maps can be used to simplify one of the expressions in part A. Okay, this one. Draw loops around appropriate groups of ones to produce an optimal sum of products for the single output table that can be simplified in part B. This cannot be simplified because they are not in position to be put together and form loops, so they will always be separate, and this expression will never be simplified, not simplified whatsoever. But we can simplify this part by making three different loops. We cannot make loops for three, but we can make loops for two. So we have simplified it this way. Let me make three different colors. 1, 2, 3. Okay, so let's first do with the blue one, light blue one. A is same while B is changing, so we leave it. A is same while B is changing. All right. And the red one, A and B both are same. And then yellow one, A is changing while B is there. So this is for X. This is for Y, sorry. So write the simplified sum of expressions for this output in part C1. Okay. Now, this is it that we have done. A plus AB plus B. Now, part D. Part D says identify a common logic circuit given by the truth table in part A, which part C we have covered, Mustafa. Part D, identify the common logic circuit given by the truth table in part A. Give the use of each output. Logic circuit is basically the one that we have is full adder. How we have identified that it is a full adder? Because it has got two outputs. Okay, and if there are three inputs, then it is full adder, and if it has two inputs, then it is half adder. So this is full adder. Use of X is basically sum. Use of Y is basically carry. Hold on. Complete these statements about a virtual machine. A virtual machine is dash that enables a dash computer system. A virtual machine is a software that emulates a different computer system. A virtual machine allows multiple dash operating system to run on one computer using a dash operating system. Multiple guests operating system to run on a single host operating system. Okay. Anita is studying computer science and she is confused about some of the computer security terminology as some of the words are similar. Anita wants to know the similarities, features that are the same, and differences, features that are different between some of the terms. Give the similarities and differences between public key and private key. Uh, Used in asymmetric encryption, found in same certificate as a pair, uh, both can encrypt and decrypt. That's it. Differences. Uh, Private key is secured with the owner. Public key is given to public key is basically given to others. Given is also called distributed. Let's call it distributed. Public key is distributed to others. I think that is enough. Otherwise, you can say that public keys are used to encrypt. When public keys are used to encrypt, only private keys can decrypt. All right. But that's not necessary. I don't think it is necessary over here. So give the similarities and differences between digital